happens if we want to find the area under the curve between values that are not part of the 68, 95, 99.7 rule? For example, if we're looking at that test score with the average test score of 80, maybe I want to know the percent of students who were between a 78.6 and an 82.1. Well, those are not multiples of the standard deviation, so I can't use that rule, but I still want to find this area. It turns out that's actually fairly tricky. It requires a good bit of calculus, which we are not going to get into, and which, quite frankly, is a kind of a waste of time for most statisticians. So instead of that, we're going to perform a little bit of math magic, turn this distribution into our standard normal distribution, and the standard normal distribution is so common that people have calculated areas for us. All right, so if you look at this curve, right now the mean is at 80. So suppose I shifted it over by 80 points. If I shift it over by 80, then all of a sudden I've got this curve and the mean is at 0. Right? How wide is it? Well, the width depends on the standard deviation. For this particular curve, I might take this width and smoosh it down some, and when I smoosh it down some, that gives me a standard deviation where sigma is equal to 1. Right. Sometimes we have other normal curves. This one again, I'm going to move over by 3. And in this case, I might have to smoosh up in order to get the standard deviation to be equal to 1. In either case, the shifting over and the smooshing is done with our standard formula, x minus mu over sigma. This is standardizing a value. Right? So I'm going to take x, which is some value, which might be that 82.1, right? If that's what I know what the score was. The mean, so whatever the mean was for that particular example, in our case it was 80. And then standard deviation, again for our particular example, was 3. So what I would do is plug in x is 82.1, mean is 80, standard deviation is 3, and solve for z. This would tell me the standard point on the standard normal curve for a test score of 82 when the mean is 80 and the standard deviation is 3. All right, if I do this calculation with the numbers I plugged in here, I get out 0.7, which means on this curve, the score, right, this was the test score, of 82.1 is equal to the z-score, I probably shouldn't have used the word score, so this is the z-value or z-score of 0.7. So when I have a test with a mean of 80 and a standard deviation of 3, a test grade of 82.1 is the same as a z-value of 0.7, okay? Which means that if I'm the student who got the 82.1, then I am 0.7 standard deviations above the mean for the class. All right, now the good news is we can take any normal distribution and do this transformation with specific values so that we can figure out what the z-value is. After we figure out all the z-values, we'll find percentiles, and we'll do that in a new video. Here we're just going to go through a couple of examples. Standardize the point 12 if mu is equal to 18 and sigma is equal to 2.4. So to standardize, I want to find the z-score. So z is equal to 12 minus 18 over 2.4. We'll put that in our calculator, and we get negative 6 divided by 2.4, which comes out to negative 2.5. So if I have a point at 12 when the mean is 18 and a sigma is 2.4, I am 2.5 standard deviations below the mean. Here, find the z-value if, that should be an if, x equals 9.6, mu is equal to 7, and sigma is equal to 0.9. Again, we'll plug these in. So z is equal to 9.6 minus mu, which is 7, over 0.9.